Question of the Week from the Naked Scientists.
Hello, it's time for another Question of the Week from the Naked Scientists with me, Diana O'Carroll. This week we're taking an aeroplane to the gym.
Hi, my name's Kian from Sydney, Australia, and the situation I've got is there's a plane that's standing on a runway that can move kind of like a really large treadmill. The plane moves in one direction while the treadmill moves in the opposite direction. The treadmill has some sort of control system that tracks the plane speed and tunes the speed of the treadmill to be exactly the same but in the opposite direction. So the question is, can the plane take off?
Is this setup going to be a help or a hindrance? Here's our expert to find out.
Hi there, my name is Tim Saby, and I'm a pilot and Cambridge physics graduate. In order for an aircraft to take off, it must have sufficient vertical forces to counteract its weight. The major component of this upwards force is lift. Now, lift is generated by airflow over the wings, creating a lower pressure distribution on the upper surface compared with the lower. This has the effect of deflecting air downwards as it passes over the wing. The equal and opposite reaction force to this is upwards and called lift. Lift is dependent on the aircraft's speed, so it must be at sufficient speed on takeoff, typically 130 to 150 knots for a commercial jet, in order to produce the lift to take off. The second upwards force is the vertical component of the engine's thrust, as when the aircraft nose is pitched up, part of the thrust vector will be vertical. The aircraft will be accelerated down the runway by its engines. These accelerate backwards, and again the equal and opposite reaction force on the plane is in the forwards direction, known as thrust. In the situation described, there is a conveyor belt which automatically tracks the aircraft ground speed and moves at that speed, but in the opposite direction. Since the aircraft is not accelerated by means of contact with the ground such as a car is, the only effect will be that the wheels spin faster, so there's more friction. The aircraft will still be able to accelerate to the speed that produces enough lift to take off. This, however, will increase the runway length required, but given that is sufficient, it will still be able to take off.
The bottom line is, a plane is driven forward by its jet or propeller engines. It doesn't have powered wheels like a car. In terms of moving forwards, the wheels on it act purely as a friction-reducing mechanism, enabling the plane to reach high speeds without the fuselage dragging on the runway. The treadmill would A. have the wheels spinning twice as fast as normal, and B. generate a fair bit of friction which might extend takeoff time and distance. But ultimately the plane would move forwards, and as long as it's moving forwards in relation to the ground and fast enough, there would be enough airflow over the wings to generate lift and make the plane take off. But what if a plane gained its takeoff speed from motorised wheels?
Hello, I'm Terry Holloway. I work for Marshall Cambridge as the Group Support Executive. In this particular instance, the assumption is that the airplane is sitting on this mobile conveyor belt runway. As the airplane gains speed and goes forward, so the conveyor goes backwards at an identical speed. Let us say hypothetically that this particular airplane we're talking about would normally take off at 100 miles per hour. When it reaches a forward speed of 100 miles per hour, in other words, its wheels on the runway, the conveyor is going backwards at 100 miles per hour, but the airplane's speed through the air is zero. There's no air flowing over the airfoil section of the wing, which produces the lift. Therefore, the airplane won't fly.
But there aren't any gliders that take off using motorised wheels, for the simple reason that as soon as they're lifted from the ground, they could no longer gain any forward propulsion, and that would be a bit of a rubbish flight. On our forum, Sophie Centaur, Turnip Sock and Bored Chemist all came up with the same answer as our experts. So here's another challenge for you lot.
Hello, my name's Tom Gallard from London, and I'd like to ask, how is oxygen made and recycled in the International Space Station?
After dealing with old spacer, I'll be handling this slippery one.
Hi, this is Robin. I'm calling from California in the USA. I had a question about electric eels. I was wondering, how do they themselves do not get hurt by the electric shocks that they use to communicate or stun prey? And since they're in water, how far does the current carry?
How is breathable air made, and however do electric eels work? Email me at questionoftheweek@thenakedscientist.com or have a scribble on our forum. That's thenakedscientist.com/forum.
Question of the Week is part of the Naked Scientists podcast and supported by the EPSRC, the Wellcome Trust and UK Fast. Look us up online at nakedscientists.com.